In this video, I'm going to go over 3 new tools in Alteryx. And these 3 tools are in the join category here. And I've made them favorites. It's these 3 here: append fields, join, and union. I'm going to go over them in the order: union, then append fields, and then join last. Join, of the 3 tools, join is the one you'll use that will be useful most often. And with these 3 tools, they all are used to join 2 data sets together. So if you imagine the data sets, we can call one data set A, one data set B. You'll use a union tool to sort of vertically stack A on top of B or B on top of A. And in that case, you want the variables in A to be the variables in B. You want the 2 data sets to share the same variables, although they don't have to share the exact same variables. But that's what, in general, when you use the union tool, that's what you want. With the append fields tool, your data set A and data set B don't share a common variable. And the append fields tool performs a Cartesian join. And with that, you view dataset A as the target and dataset B as the source, and you append dataset B to dataset A. So every row of dataset A, each row of dataset A, to each row of dataset A is appended all the rows in dataset B. So the resulting dataset C that results from this joining of A and B together has the number of rows in A times the number of rows in B. So if there's 10 rows in A and 5 rows in B, each row of A is appended to each row of A are going to be the 5 rows of B. So for each row in A, there's going to be 5 rows, right? And so once you do this append, dataset C will have 50 rows in it. So append fields can quickly get out of hand in terms of your data can explode. That's what the append fields tool does when you want to do a Cartesian join. And I'll show an example of that. It's not used very often. In practice, I haven't seen it used very often, and the union tool isn't used very often either. The tool that's used the most often when you want to join data sets A and B together is the join tool. And the join tool, you could rename it, call it the merge tool, because merge is more intuitive of what it actually does. The join tool, what it does is data sets A and B have to have at least one variable in common. So there has to be at least one variable in A that's also in B. If data sets A and B have no variables in common, you can't use the join tool. So data set A and B have at least one variable in common. It could be more than one, but at least one. And for most cases, there's one variable in A that you care about, and that variable is in B as well, and you want to join these 2 data sets together on that variable. And we're going to show what that does. So that's about the best I can explain these 3 tools without actually showing you examples of data sets. So let's get into some examples. So let's show you the union tool first. So I'm going to bring in 2 data sets. So I'm going to have 2 input data tools. And the first data set is on my desktop here. Sales data 2019. And the second data set is also here on my desktop. Sales data 2020. And let's attach a browse tool to each data set so we can visualize the data. So we're going to run the workflow here. So the first data set, sales data 2019, this is the data set. You can see we have 7 fields or 7 variables. We have order date, region, rep, item, units, unit sales price, and total revenue. So what this data set is, we're a company and we sell office products. And these are our orders these are the orders that we sold in 2019. So in row 1 here, we made a sale on January 6, 2019 in the East region. Now the last name of the sales representative who made the sale to the customer is Jones. That's this variable, the rep. And the item that we sold or pencils, we sold 95 units of this item. We charge $1.99 per unit. This isn't 95 pencils per se, it's 95 units of the pencil item. So 1 unit might contain 30 pencils. But for 1 unit of the pencil item, we charge $1.99. And then the total revenue column is just the product of price and quantity. So each row represents a unique order. So that's the sales data 2019. And then in sales data 2020, we have the same 7 fields, right? Order date, region, rep, item, units, unit sales price, and total revenue. But the data is just for 2020. So this is our 2020 sales data. So you can imagine our company, we have, we keep track in a CSV file or an Excel file, our 2019 data, and then a separate Excel file, we keep track 2020. But what if we want to put these 2 files together into 1 file? That's what the union tool does. So we'll bring the union tool here, and we're vertically going to stack either the 2019 data on top of 2020, or if you want the more recent data on top, we'll put 2020 on top. But you could do that with the union tool. So here's the union tool configuration. You usually want to auto configure by name. Just keep the default there. When fields differ, what does that mean? That means if this data set here, we'll call this data set A and this is B. So if A and B don't have exactly the same fields, and when I say the same fields, I mean the field names have to be exactly the same. So if we go here to data set A, you see the field name here is order date with no space. Capital O, capital D, lowercase, everything else. So if that field is not also in data set B, then fields differ. But it is, of course. So when fields differ, we can do one of 3 things. By default, it will give us a warning, but it will continue processing the records. Or we could change that to ignore right here, don't give us a warning, or we could change it to error, in which case it wouldn't run, the workflow wouldn't run. We can also, if fields differ, we can say output all fields or output the fields that don't differ, the common subset, the fields that are common. And usually we'll output all fields. And I'll show you what will happen if we try to use the union tool here if the fields differ. But usually the fields don't differ. Because like I said before, you want data sets A and B to have the same variables. You don't want any field in A that's not in B, and you don't want any field in B that's not in A. And if that's the case, if that holds, then both data sets will have the same fields. And then for the output order, we set what order do we want. Do we want, first I got to attach the 2. So attach this here and attach this here, and it called that 1 and that 2. So do we want 1 on top of 2, or do we want 2 on top of 1? And we can change that right here. If you don't set a specific output order, it defaults to putting 1 on top of 2. So we'll run this, and we'll look. We have a new data set. We'll call it C, and it's just A stacked on top of B. Dataset A had, or dataset 1 had 22 records. Dataset 2 had 21 records, and you can see now dataset 3 or dataset C has 22 plus 21, 43 records. Now let's have a look at what would happen if the fields differed. So if I go actually change this file, let's change the order date field. And instead of calling it or naming it order date with a no space between order and date, let's put a space between order and date. So I'm actually going to go to my desktop here and open up sales data 2019. And you see the order date. I'm just going to put a space right here. Save this. save this, and then let's go and do the input tool again, link it to the data set again like this. So now in sales data 2019, the first field, order date, is not named exactly the same as in the 2020 data set. And then let's look at our union tool. When fields differ, continue processing records, and you're going to see what's going to happen. You see now there's 8 total fields. So when it's stacked one on top of 2, in dataset 1, the order date variable is named this. But in dataset 2, the order did not have this variable name, right? So it's just null here. And then in dataset 2, we did have the order date variable named this way. So this is populated, but in dataset 1, it doesn't recognize this as a field. So it just puts null there. So that's what it looks like. All right, let me go back and undo what I did. That was just for illustrative purposes. Let's undo what I did. Let's save this. And let's show you guys what the Append Fields tool does. So that's the union tool. Append Fields. Let's look at our data here. Append Fields is not used very often. Actually, let me run this so that it's now it looks fine. Append Fields is used probably the least often of these 3 tools. Join is the most often used, then union, then Append Fields. Append Fields, let's see what we would want to do. Let's say, let's first attach a unique tool and find, if we look here at let's get the unique regions and, or no, let's get the unique last names of the sales representatives that work for our company, and then the unique items that we sell. So let's do that. So let's go here to get the unique tool, and we want to get unique region, no, unique rep, and then another unique tool, and get unique item. And you see, here's the last name of our, these are all of the sales folks that work for us. And then here are all the items we sell. So let's do a select tool now and only keep those 2 variables. So uncheck everything except for rep in this data set, and then uncheck everything except for item in this data set. Let's run this. So here we have a little data set. These are all of our sales reps. These are all of our items we sell. So we have 10 sales reps selling 5 items, basically. And what if we wanted to know what are all the possible combinations of sales reps and items? Right? What if we want a data set the output would be all the combinations? So Andrews could sell one of the 5 items. So Andrews pencil, Andrews pen, Andrews notebook, Andrews binder, right? Those are all possible combinations. And then Gil pencil, get all the possible combinations. And we know if this data set has 11 reps and the other one has 5 items, we know there's going to be 55 possible combinations because each one of these 11 people could sell one of those 5 things. There's going to be 55 possible combinations, and you can visualize what it is in your head. But what if we had, 1,000 reps and 10,000 different items, and we wanted to quickly make a data set that is all the possible combinations. Well, that's what you can do with the Append Fields tool. So let's bring, or this is one potential way that you could use the Append Fields tool. So you bring the Append Fields here to the workflow, to the canvas, and you notice there's a T anchor and an S anchor. T stands for target and S stands for source. So the rows in the target data set, each row in the target data set, we're going to append all the rows in the source data set. So we want to append to each row in our target data set of sales reps all of the potential combinations in our source data set for the items. And you can see the configuration here. It's pretty straightforward. You really don't usually have to do anything here. Notice that it says down here, warn /error on too many records being generated. Error on appends of more than 16 records. That's the default. So if the source data set has more than 16 rows, then this workflow won't run. And Alteryx does that by default to protect you, because a lot of times data sets are very large. Your target data set may have 2 million rows, and if your source data set has 5 rows, then the output of this append, each of those 2 million is going to get 5 rows. So it's going to be 10 million rows. And so quickly your data set can blow up and you won't have enough memory on your computer to process all those records. So Alteryx, the developers realize that, and they by default, they won't let you append more than 16 records. So the source data set can't have more than 16. But you can override that by going here and saying allow all appends, or only give me a warning on appends of more than 16 records. Since our source data set does not have more than 16 records, it only has 5, right? 5 items, then it doesn't matter what we choose here. But I get in the habit of doing allow all appends. So let's run this. And what the Append Fields tool does is it does a Cartesian join. So for each rep, we have so each row is a rep item combination. So there's 55 rows here, there's 55 combinations. You can see clearly what it did. It's a Cartesian join. So these are all possible combinations of sales reps and items they could sell. And then we could go back and look in our actual data. Jones here on January 6, 2019 sold the item pencils. So that's one of the possible combinations, but we could answer the question in our actual data over the last 2 years, 2019 and 2020, were all possible combinations realized, right? We know there's 55 possible ones, but were all 55 of those realized? So we could match. The way we could do that is just pull out the unique rep item combinations here. And if there's 55 of them, then we know there's only 32 of them, right? If there were 55 of them, then we know all 50, because we know there's 55 total combinations. There's only 32. That means there's 23, right? 55 minus 32. There's 23 combinations that weren't realized this year. Which combinations were those? Well, we could figure that out by doing some stuff with this and this, looking what's in here that's not in here. So yeah, that's the Append Fields tool. Let me put this maybe right here. And then the final tool I want to teach you all is the join tool. And join is used when your data sets A and B have at least one common variable. So let's go back to our right here, and let's look at what we have. So in this data set, you can see our 7 fields. I want to bring another data set into the workflow here. Let's bring in our sales data 2 right here from the desktop. And we'll attach a browse tool. And let's run the workflow, and let's visualize what this data set is. So this data set also has 43 records, and there's a this data set has some fields that are common to this data set here. Order date is common, item is common, is common, but it has some fields that are not common, like unit cost, total cost. So this data set has the order ID number for all of the orders that we made for all 43 orders we made over the 2019-2020 time period. This data set has the order ID number. It has the item, the order date, what it cost us to either make or buy each unit from our supplier, and then the total cost. So if we can get this data set here together with this data set, then we could calculate profit, right? Because profit is revenue minus cost. This data set has the information about revenue. The other data set has the information about cost. We can't calculate profit from either data set because with each data set there's something we're missing. So we need to join these two data sets together or merge them together. And again, you can only do that with the join tool if there's at least one variable that's common to both data sets. And the variable we're going to join on is order date. It's common to both data sets. In this example, the order dates in this data set are exactly the same order dates in the other data set. In other words, there's no order date here that's not in the other one, and vice versa. That does not have to happen before you join. You can still join if they don't have exactly the same values for that common field. You can think of it like a Venn diagram. In this case, the two data sets overlap perfectly on that variable that we're joining on, but they don't have to overlap perfectly. So let's bring the join tool in. And what we want to do, you see the join tool here has an L node and an R node for the input anchor. L stands for left, R stands for right. And in this case, it does not matter which data set we attach to the L node and which data set we attach to the R node. That's different than when we did for the append fields tool, where it does matter what data set we attach to the T node and what data set we attach to the S node. Append fields tool takes each row of T and appends to that row all the rows in S, not vice versa. But with the join tool, it doesn't matter which data set you attach to the L or R, it does the same thing. So let's attach this one to the L, this one to the R. Move this browse out of the way here. And here's the join tool configuration. By default, it says join by specific fields, and that's what you want to do. You want to choose the field in the left data set that's common to the field in the right data set that you want to join on. And you can join on more than one field, but order date is the one we're going to join on, and it automatically fills it in the right data set. Now, if there are no fields in the left data set that are in the right data set, then the two data sets don't share a common field, and it won't work. And then down here, our output data set is going to either go, we're going to have three different outputs. We're going to have the L node output, the J node output, and the R node output. So what this join tool is going to do is it's going to start in the L data set, and it's going to start in the first row. And on that variable that we're joining on, order date, it's going to look at the value in the first row for the order date. And then it's going to go ask the question, in the R node data set, do I see that value for order date in any of the rows in the order date column of the right data set? If yes, then it takes that first row of the left data set and that corresponding row in the right data set where it found that value, and it puts them side by side. And that goes in the J output. If no, then it takes that first row in the left data set and a row of nulls and puts it in the L. And puts the first row in the left data set and a row of nulls right beside that. And it puts that in the L node. So the L node contains all rows of the left data set that are not in the right data set on that variable we're joining on. And after it's gone through all the rows of the left data set answering these questions, then it does the same thing with the right data set. It starts with row 1, order date column. What's the value? And then it asks the question, can I find that value anywhere in any of the rows of the left data set? If yes, then it puts row 1 of the right data set and the corresponding row in the left data set side by side in the J node. Now, if that's already been put side by side in the previous, when it went through the previous iteration with the left data set, if we already have that, then it won't put it again. It won't duplicate. And if the answer is no to that question, then it puts that row, that first row of the right data set, and a row of nulls beside it in the R node. So the R node contains all the rows of the right data set that are not in the left data set on that particular variable. So you can think about it like a Venn diagram. L contains all the data in the left data set that's not in the right data set on that particular field. J contains all the data that's in both data sets on that particular field. And then R contains all the data in the right data set that's not in the left data set on that particular field. Now, as far as your output, you have this option of what fields you want to output. And by default, it lists all the fields. First, all the fields in the left data set, and then underneath that, all the fields in the right data set. So if the two data sets have common fields, you don't need to output those common fields twice, right? So like order date is in the left data set, it's also in the right data set. I can just uncheck this. I don't need to order date. It's just going to say the same thing. I can either uncheck the right or uncheck the left. It doesn't matter. I don't need that output twice. Regions in the left data set, but it's not in the right data set, so I'll keep that checked there. Rep is in the left, but not in the right, so I'll keep that. Items in the left, it's also in the right, so I can remove either the left or the right, doesn't matter. I don't need it both times. So I'll just remove it from the right. In terms of the output, like once it outputs those rows into L, J, and R nodes, what fields is it going to keep? That's what this is telling. That's what we're telling Alteryx when we were choosing these things. Units is both in left and right, so I don't need it both 2 times. And then we have unit sales price in the left. We have unit cost in the right. I'm going to move unit cost right up to be right underneath unit price. And then we have total revenue. And then we have total cost. And I'm going to move total cost right underneath total revenue. And then order ID is not in the left data set, but it is in the right data set. I'm going to move that up right underneath order date. Yeah, and by default, since order date is common to left and right. So in the right, when it outputs it, it can't output. In Alteryx, you already know that no data set can have 2 fields with exactly the same name. So it renames the right when you see. But we're not going to even have that in the output anyway. We unchecked it. So let's run this and see what we have. So in the L node, if we go back and look, so here's our left data set. We're joining this to the right data set on order date. So if we look at this value here, first row of the left data set, is that value anywhere in the right data set? Yeah, it's right there. And I've already said that both data sets have exactly the same order dates. There's perfect overlap. So the L node is actually going to be empty. There are no rows in the left data set where in the order date column, we can't find that value in the right data set in any of its rows. No rows exist in the left data set where that is true. So L node will be empty. You can see it's empty. R node also will be empty. There are no rows in the right data set for which we can't find the same order date in one of the rows in the left data set. So R is empty. And so there's the join. It's called the inner join, the inner join. And so now we have this data set. Now it has 10 fields. We have order date. We've got the order ID matched to the order date. We've got the region. We've got the rep. We got the item, how many units of that item we sold. This is what we charged per unit to the customer. This is what it cost us per unit to produce or buy from our supplier. This is the total revenue of the order. This is the total cost of the order. And clearly you can see now we can create a profit variable. We can find total profit for each order would just be the difference between the total revenue and total cost. And we can go from there analyzing the data. So I hope this video helped you first understand technically what does the union tool, what does the append fields tool, and what does the join tool do. But maybe more importantly than that, hopefully I've given you an actual context where you see how it can be helpful to actually use these tools in data analytics. And that concludes this video.